Okay, so we are going to go over deriving all of our unit circle values quickly. The first thing I want to point out is that I choose to ignore my 45-degree angle reference lines. So because of that, I'm going to highlight them purple, and I'm going to ignore those 45-degree angle reference lines. Instead, what I'm going to focus on are my 30 and 60-degree reference lines. And I'm also highlighting my axes. Okay, and let me grab, I don't really have a pen, I'm going to use a Sharpie. Okay, so whenever we start off, we are at 0 degrees. If we do one full revolution, we are at 360 degrees. Also, we are at 0 pi, and if we do one full revolution, we are at 2 pi. If I were to only go half of a revolution, I would have half of 360 degrees, which is 180 degrees. Notice this is also a straight angle, or straight line. Half of 2 pi is equal to 1 pi. At this point, you might notice that the unit circle here has been divided up into numerous congruent parts. What I like to do, and this is what I did in class, is I told the students we were going to consider just 1 pi. Hold on one second. I have someone knocking. Okay, so I'm back. What I did with the students in class is I took the unit circle, we filled it in half so that way we could look at just 1 pi. And if I ignore these pink lines, you would notice that our pi is broken up into 1, 2, 3, 4, 5, 6 congruent parts. I'm going to kind of shade that with a highlighter to kind of emphasize on that. Here's 1, here's the 2nd, there's the 3rd, 4th, 5th, and 6th congruent part. We're going to actually use that concept of 6 to count up in terms of radians. So here I have 1 pi over 6. Here I have 2 pi over 6. Here I have 3 pi over 6. Here's 4 pi over 6. Here's 5 pi over 6. And then if I were to come down here, I would be at 6 pi over 6. And that fraction would reduce to 1 pi. Now, if I unfold this paper, we can actually continue this counting process all the way around. So this was 6 pi over 6. This is 7 pi over 6. Here's 8 pi over 6. 9 pi over 6. 10 pi over 6. And 11 pi over 6. We can worry about simplifying our fractions here in a little bit. I want to go back to this concept of looking at just half of the unit circle. Now notice we took this 1 pi, we divided it into 6 congruent parts. We were looking at our radian values or measures just a moment ago. We now need to consider our degree values. If we have 180 degrees in total, and we divide that 180 into 6 equal parts, that tells us that each little sector is worth 30 degrees. So I'm going to go up in increments of 30 degrees. So 0 plus 30 is 30, 30 plus 30 is 60, 60 plus 30 is 90, and then we're going to have 120, 150, here's 180. I'm going to go ahead and unfold the circle so we can keep on going all the way around. We have 210, 240, 270, 300, and 330. Okay, so we've made it all the way around with our radian values and our degree values just for our 30 and 60 degree reference angles. Now I'm going to go ahead and simplify these fractions. 1/6 pi does not reduce. 2/6 pi does. It's equivalent to 1 pi third. 3 pi over 6 is equivalent to 1/2 pi. 4 pi over 6 is equivalent to 2 pi thirds. 5 pi 6 does not reduce. Here's our 1 pi. 7 pi over 6 does not reduce. 8 pi over 6 does. That's equivalent to 4 pi over 3. Okay, 9 pi over 6, it reduces to 3/2 pi. 10 pi over 6, that reduces to 5/3 pi. And then 11 pi over 6, it does not reduce. All right, awesome. So now we're going to look at our 45-degree reference angles. Okay, and so we can do this a couple of ways. Some students like to notice the pattern that these lines that I have highlighted as purple, my 45-degree angles, they're just 15 degrees greater than or less than their surrounding angles. So 30 plus 15 gives me 45. 120 plus 15 gives me 135. And then so forth. We could keep doing that. But really, what I've highlighted, these are called 45-degree reference angles, meaning that their overall angle value difference from the x-axis is going to be 45 degrees. So notice 0 plus 45, that got us here. To figure out this measure, we could have subtracted 45 from 180 to get 135. To get this measure, we could add 45 to 180 to get 225. And then to get this measure over here, we could subtract 45 from 360 to get 315. So there are multiple ways to go about finding these values. I don't really care which way you take. If we were to fold our circle back in half, and if I were to highlight my y-axis, and if I could visualize that all of these blue lines are gone, so that's kind of hard to do, but if you could block out all of those blue lines, you would notice that our 1 pi has been broken up into 1, 2, 3, 4 congruent parts. So because of that, we can count up in terms of fourths. This is 1 pi over 4. This right here is 2 pi over 4, which is 1/2 pi. We've already got that. This is 3 pi over 4. This right here is 4 pi over 4. Should have probably highlighted my x-axis too. This would be 5 pi over 4. This is 6 pi over 4. And this right here is 7 pi over 4. To finish the circle, we would be at 8 pi over 4, and 8 divided by 4 is 2. We already have that annotated. So we have the majority of our values of our unit circle filled out. Now we need to think about our ordered pairs. So our ordered pairs that we are most familiar with are the ones that lie along the x and the y axes. And this is a unit circle, meaning that the distance from the origin to the outer edge is only 1 unit. So if I were to start at the origin and move over to the right 1 unit in the positive x direction, I'm going to have a positive 1. I don't go up or down at all to get this point, so my y value is 0. Likewise, if I start at my origin and I go back 1 unit in the negative x direction, I'm going to be at negative 1, and my y value is 0. If I start at the origin and go up 1, but I didn't go to the left or right at all, I'm going to have 0, positive 1. And if I start at the origin and go down 1, I didn't go to the left or right at all, so my x value is 0, but my y value is negative 1. For all the remaining ordered pairs that go around the unit circle, they're each going to have denominators of 2. So I like to go ahead and go around the whole unit circle and put 2's everywhere. Also, we need to think about our quadrants sign values, and not sign like the trig function, but positive and negative sign of your x and y coordinates. If I were in the quadrant 1 up here, my x value is going to be positive and my y value is also going to be positive. If I were in quadrant 2, moving from the origin, I had to go back in the negative direction, but I would have to go up in the positive direction for y. Down in quadrant 3, starting at the origin, we have to go back and down, so it's going to be negative for our x value and negative for our y. And in quadrant 4, we have to go forward in the positive x direction, but down in the negative y direction. Okay, in the trig land, we have our x and y coordinates called something else. Our x coordinate corresponds to cosine of x, and our y coordinate corresponds to sine of y. So traditionally, you were taught that you have an x and y ordered pair, which that is true, but here for trig land, we've got cosine as x and sine as y. Your sine goes up and cosine goes down whenever we are working in quadrant 1 and counting. Okay, so I'm going to look at my sine values, that's my y's, and I'm going to have 1, square root of 2, square root of 3. Cosine goes down, so it's going to have our numerator values of square root of 3, square root of 2, and 1. Now, the nice thing about this is you can then use properties of reflections to determine or derive these remaining ordered pairs. Okay, what I like to do is I like to just find a point and reflect it over the y-axis, and then reflect it over the x-axis. Again, reflect it over the y-axis. And I'm going to go ahead and just complete this little sketch of reflections just to kind of make it complete. I'm also going to highlight my ordered pair here just to really emphasize on what's going to happen. My overall value of my x and y coordinates in each of these highlighted spots will remain the same. The only thing that's going to change is whether or not it's positive or negative. So in other words, every single ordered pair is going to have 1/2 comma square root of 3/2, but we need to determine which quadrant our x and y values are negative in. Okay, so remember in quadrant 1, both of our values are positive. In quadrant 2, our x value is negative, our y value is positive. In quadrant 3, both our x and y values are negative. And in quadrant 4, x is positive, y is negative. Okay, from this point, we can go ahead and reflect the remaining points. So I'm going to use green next. Okay, so everything that's highlighted green is going to look exactly the same as far as the overall absolute value of the x and y coordinates. The only thing that's going to change is whether or not they are positive or negative, depending upon what quadrant we are in. Okay, remember in quadrant 2, our x value is negative, our y value is positive. In quadrant 3, both our x and y values are negative. In quadrant 4, our x value is positive, but our y value is negative. And last but not least, we need to reflect our remaining ordered pair at 30 degrees all the way around. Okay, everywhere that's highlighted yellow, our ordered pairs are going to be identical as far as their overall absolute value. So the square root of 3/2, comma 1/2, it's going to go everywhere. Okay, last but not least, we need to address our positive and negative values in quadrant 2. Our x value is negative, our y value is positive. In quadrant 3, both our x and y are negative. And in quadrant 4, the x is positive and the y is negative. Okay, so that is it on the unit circle. We are going to expand a little bit further on it, and we're going to talk about which quadrants certain trigonometric functions are positive in versus negative, because we actually have 6 trigonometric functions. We have sine, we have cosine, we have tangent, we have cotangent, we have secant, and we have cosecant. Okay, sine and cosine are cofunctions, tangent and cotangent are cofunctions, secant and cosecant are cofunctions. Their abbreviations are as follows. I don't have space, so I'm going to skip down here. So sine, cosine, tangent, cotangent, secant, and cosecant. And so later we are going to look to see which quadrant these functions are positive or negative in. You guys should be able to determine which quadrant sine and cosine is positive and negative in. The other ones, though, I'm going to have to teach you about that. So that will come this next week. Alrighty, thanks.